we're learning about functions is the main topic on this. What we're going to start with on this is just doing some graphing of functions. Okay, so if I want you to graph something at this stage in the class, then what you want to do is make a table of values. So on the table of values I give you, just put x and y, and then we're going to pick some numbers. Now, I want you to pick these numbers on this problem. We're going to do -2, -1, 0, 1, and 2. Okay? And you can pick whatever x you want to, but it's good to do some negatives, 0, and some positives. Then all you do is plug it into your function. Now, you can fill this out in your head. You're just taking x and squaring it, so that would be 4. This would be 1. You don't have to write all that out because you can do this in your head if you want to. That would be 0. 1 to the second would be 1. And then 2 to the second would be 4. Okay? And then what you're going to do is you're going to plot those points. And when you're doing this on My Math Lab, you'll just kind of put your mouse, you'll click wherever the point is, and it'll put a dot there for you is how that works. So let's just plot the point -2, 4. So that's your first point. Then plot -1, 1. That's your second point. 0, 0. And 1, 1 would be over 1, up 1. And then 2, 4 is over 2, up 4. And then connect it into this shape. Now it goes on forever, so put an arrow at the end like that. You may know this from your background. We call that a parabola, is the shape on that, y equals x squared. Okay, so one of the things we're going to do at the start here is just do some graphs with table of values. We'll learn lots of other techniques this semester. Everybody with me what I did there? Okay. So it's a matter of choosing x, calculating y, plotting points. Okay, that's what way we start with our graphing. Okay, this one is backwards. It says x equals y squared. So what I'm going to do on this one is I'm going to do something a little bit different. We're still going to do x and y, but what we're going to do is I'm going to go ahead and show you how to do this by solving an equation, and I think you'll do it better this way. All right, so what we're going to do is if you want to make the y squared become y, you know what to do to make y squared become y from your background. Square root. Okay, so we're going to do the square root of both sides. And when you do that, you got to put a plus or minus. Anytime you take a square root of both sides, you get two answers. So that would be y equals plus or minus the square root of x. Okay, then we're going to choose some values for x on this, and we'll end up with something that looks a little bit different. Okay, so what we're going to do on this then is we're going to we get two answers for this. So what I'm going to do on this is just have you do, I'm going to only choose numbers I know square roots of. So for instance, I know the square root of 0. I also know the square root of 1. Now let me put the 0 up here though. Okay. And I also know the square root of 1. Square root of 1 is 1. So what we're going to do is just put a 1 there. And then I also know the square root of 4 as well. And I also know the square root of 9. Okay, so I'm going to use those. All right, so what we end up getting then is if we just do the square root of 0, that'll give 0. Now remember, we have the plus or minus. So if we do the square root of 1 with a plus or minus, we either get 1 or we get -1. Okay, you're going to get two answers on that. You're going to get two different points. Same thing here if you do the square root of 4. Square root of 4 is 2. So we'll either get a 2 or a -2. Okay, and you can't forget those 2 points. If you do a square root of both sides, you have that plus or minus. And then what would you get on the next one if it's 9? 3 and -3. Okay, so square root of 9 is 3 or it's -3. Okay, like that. Okay, so what's going to happen is this graph is going to look like the first graph, but it's going to be tilted sideways. So if you plot your points, the first point you want to plot is 0, 0. Okay, then you want to do this. You want to plot the point 1, 1, and you want to plot the point 1, -1. Okay, so it goes like that. Then you go to the next one. It's the same idea. Over 4, up 2, or 4, -2. Like that. And then the last one, you just want to go over to 9, up 3, and down 3 like that. So what your graph would look like would be like that. Okay, that would be the graph. So what do you notice? The one of it, all it did was it changed it, kind of rotated it like 90 degrees to the right. That's because of where the square is. Okay, so that's how that goes. So this is something you might have to review. If you do a square root of both sides, that introduces that plus or minus. There's actually two answers to that. Okay, is everybody with me okay on that, what I did? Okay, all right. Okay, let's do, I'm going to kind of help you with this problem. So on this next problem, go ahead and do XY. I want you to just do this one yourself, and I'm going to give you the numbers to use. So -2, -1, 0, 1, and 2. Okay, like that. Okay, and just do that one. I'm going to wait. I'm going to do number 2 with you here. I want everybody to just do this problem. Just take a couple of minutes to do this, okay? And then just go through and calculate these things out, plot your points, and then we'll kind of see what you're coming up with as far as a shape on this. So I'm going to do a little bit of this on your My Math Lab homework and everything. You'll be doing some graphing just by making a table. Now, what happens to a negative number if you multiply it out 3 times? Do you get a negative or a positive?
Negative.
Get a negative, okay, so you're going to have some negative y values on this. Yeah, you just get one y value on this. Like the first one, you should get -8. And you just plot that 1 point. It's not like the last one where you got a plus or minus. That was because I solved the equation. Yeah.
Should we just graph it?
Yeah, just graph it. I think you'll end up having, if you do it right, it'll look something kind of like this. Okay, it'll kind of look like that. Okay. Yeah, just connect it into a curve. So let's see. What you should have here is -8, -1, 0, 1, and 8. All right, that's what you should get on your table. Now, if you plot these points, you'd have left 2 down 8, left 1 down 1, 0, 0, 1, 1, 2, 8. So that's what you should come up with. So it kind of goes like this, just connect it into a curve like that, and then put your arrows at the end like that. Okay, that's what the graph of y equals x to the third is. We're going to do this problem on the next page where it's y cubed equals x, so it's going to be a little bit different when you do it that way. All right, is everybody okay with what you just did? Okay, you calculate, you got to do your calculation right and plot points. If you can do those two things, you won't have too much trouble, I think, graphing if you're making a table of values. Okay, now this one's a little bit different. So what I'm going to do on this is, again, I'm going to go ahead and teach it this way. We're going to do, instead of a square root of both sides, we're going to do a cube root of both sides. Okay, anytime you do a third root of something to the third power, it undoes the operation and gives you y. And there is no plus or minus on an odd root. So we'd end up having cube root of x, like this, okay? All right, I'm mainly a little bit more interested that you can plot number 1 and do that better than you can number 2. I want to show you the connection between these two graphs like this. So what we're going to do on this, on our table, is we're just going to do x and y, and I'm going to give you certain numbers that I know a cube root of. Okay, I know the cube root of 0, I know the cube root of 1, and I know the cube root of 8. Okay, I also know the cube root of -1 and -8. Okay, all right, so what we're going to do is just the third root. We don't do the plus or minus because it's an odd root. So this would go like this. If we do the cube root of -8. Okay, tell me what number you would multiply out 3 times that would give you -8. -2, good. So you're just doing backwards in your head. Okay, what number would you multiply out 3 times that would give you -1? -1. -1 times -1 times -1 is -1. How about cube root of 0? Cube root of 1? 1, because 1 times 1 times 1 is 1. And finally, how about cube root of 8? 2. There you go. Okay? Right? So now if you plot your points, it'll kind of be like the first graph turned at a 90-degree angle. So you go left 8 down 2 is your first point. Left 1 down 1 is your second. Then 0, 0. Then 1, 1. And then over to 8, 2. So if you compare the graph that we did on the previous page, it just kind of rotated and flipped is what it did. Okay? All right? So I'm kind of interested that you can do y equals something. That's the number one thing for what we're doing. Okay? All right, does anybody have a question about what I did on anything there? Okay? You'll have a little bit of this on your homework, but not Not a whole lot, just a few problems where you're graphing by plotting points. Okay, so the next thing I want to talk about is a function. A definition of a function is kind of a real big deal. And what a function is it relates to sets in a certain way. All right, and the key thing on this is it says that each element in the first set is going to correspond to exactly only one element in the second set. Okay, it's real easy to explain this with examples, which is what I'm going to do. And then you also want to know this terminology. The domain of a function is the set of its first elements. That's the first set. And that's usually the x value. So you want to write down x value. So if I'm asking for a domain of a function, I'm looking at the inputs. I'm talking about the x values. And the range of a function is the y values. So we're going to focus on kind of what domain and range and what a function is for the next topic that I want to kind of get through. Okay? All right, so the easiest way to explain this is just with basic examples. Okay, I'll do several examples on this. All right, so if you look at these things I printed out for you, this is what you ask yourself. Does this thing go to one thing? Yes. Does that go to one thing? Yes. And it does for everything. So every x goes to one y. Can't go to two y's. It's got to go to one. So that one is an example of a function. The first one would be a function. Okay, the second one, again, you just ask the same question. Does the -2 go to one place? Yes. Does the -1 go to one place? Yes. How about 0? Yes. 1? Yes. 2? Yes. It doesn't matter. They don't have to be like perfect like that matched up. It's just that goes one place. So that's a function. Okay? So we would consider that would be another example of a function. Okay, let's look at the next one. This is what you look for. So the next one, okay, do you see any problem on this? The 0 goes to one place. What's the deal with the 1? It goes to two places. That's not a function. See, you can't go to more than one place, so that's not a function. That's what you look for in a function. And of course, we're going to talk about functions all semester, so that's why. Okay, if you see the x going to two or more places, you rule it out. It's not a function. Everybody understand that okay? Okay. All right, so on the next page here, all right, let's see. Let's do I'll let you kind of go through and just think through the next four problems, okay? Let's give you a few minutes to do that. Now, on this number 1, the other thing I want you to do is this. Let's just do number 1 together. So what do you think, function or not a function? What do you think? Yeah, okay, what did I say the domain was? X's. What did I say the range was? Y. So let's just do this one together. Okay, that one's a function. Yeah, go ahead.
Would you list it out like 4, 8, 12, or would you say like 4 through 12?
Doesn't matter. You just do it kind of in numerical order. So the way you want to do this is put like a set brace, and it doesn't really matter with, what order. It's just, usually just numerical. That's the preferred. Then the range is the same way. You just say 0, 10, 20. Okay, to me it won't matter, if you're doing a test or something, what order you put it in, but the preferred way is just numerical order. And then use those set braces like that. Okay, so go ahead and do 2, 3, and 4 and see kind of what you come up with, okay? And that'll kind of get us through the rough idea, I guess, of what functions are and everything, okay? You don't have to show any work on these, it's just stuff you do in your head. It's a process you do in your head. Okay. You'll see that one. That goes one place. That's good. That goes one place. That goes one place. Okay. What you always look for is look for the x going to two places or more. That's what you look for. Okay. Kim, one person. Good. Carl, one person. Lewis, one person. Okay. If you had Kim going to two people, then it's no. All right. Yeah, that's okay. That's a function. Okay, now some of you, I saw several of you not thinking through number 2 right. What did you get on number 2? Yes or no for function? That's yes, okay. Ken goes one place. Carl goes one place, so does Lewis, so that is a function. That's okay. The domain, you just write them out. Ken, Carl, and Lewis. You just write them out. And functions don't have to have numbers, and then the range is just Kathy. So it's okay if all these guys like the same gal, it's still a function, okay? All right? Okay? All right. The next one, okay, how about this one? Now it's the opposite. It's like Ken likes all 3 of these gals. Is that yes or no? That's no. He's a 3-timing man, so that's a no. That's definitely no good. Okay, so that's not a function. That's what you look for. Then the domain would just be Ken only, and then the range would just be the 3 ladies. Okay, that's it. So that's what you look for, and that's how you can tell something's not a function. Okay, everybody with me there? Okay, all right. The next one, again, you can kind of do it in your head, so let's think about this, all right? The -2 goes to one place. That's good. -1 goes to one place. 0 goes to one place, and so forth. So is that a function? Yeah, okay. Every x has one y. Now, if I snuck another number in there, then it's not a function, okay? So that would be an example of a function. And then the domain, just list the x's, so that would be -2, -1, 0, 1, 2. And then the range, there's only 2 numbers, so you just list the 2 that are there. You don't have to list them all because you're repeating yourself. So you just do that, okay? So that's what we mean by a function. Does everybody feel comfortable about what I'm explaining there? Okay, all right? Now, to further go into this, the next thing we look at is if you look at a graph, you can tell if something's a function by doing what's called the vertical line test. So the vertical line test says this: if any vertical line passes through exactly one point, you want to fill that in, then it's going to be a function. If you can find a vertical line that passes through 2 or more points, then it's not a function, okay? And I'll show you kind of what that means. Vertical line test is real easy to apply. So here's what you do. On this example down here, I'm going to take a vertical line, and that vertical line went through how many places? Went through 2, so that's not a function. That's not a function. And here's why it is. Let me just explain it this way. Like this point right here looks like it's the point 42 to me. It may not be exactly, but to make my point, here's the thing. That's the reason the vertical line test works, is because this x had 2 different y's. That's what it's doing, okay, and you can't have that. So that's what the vertical line is. Okay, the next one, if you did vertical lines through there, how many points are the vertical lines going through? Each time I draw it, how many times does it touch the red graph? Once, okay? So yes, that's a function. That passes the vertical line test, okay? That's how that goes, all right? Every x has one y. That's what you're trying to look for. Okay, the next one, this is a business graph relating average cost. What do you think on C, yes or no? Yes. Yeah, that's definitely a yes. All the vertical lines go through one point. And how about the last one? That's definitely a no. Again, what you find is you find a vertical line that goes through 2 points, then it's a no. All you got to do is find one. That's it, okay? So that's what the vertical line test does, okay? Okay, the next one here, let's go ahead and let's just plot these points. And let's just do this together. So we have the point -4, 5. So we go left 4, up 5. And you want to put an A there. B is just left 3. That's an x-intercept. C is left 4, down 5. D is what we call the origin. That's 0, 0. E is -3 and 3. And then F is over 1 up 4. And then G is over 2 up 4, like that. Okay, would that be a function? Yes or no? No, how come? Yeah, okay, if you take a vertical line right there, it would go through 2 points, right? So in other words, this x has 2 different y's. That's what makes it not a function. Same thing here. Same x, different y's. So it fails the vertical line test on this, so that's not a function. Okay, and it's because of those points and those two right there. Same x going to two different y's, that's what makes it not a function. Okay, all right, now the next thing we're going to go ahead and look at is like linear functions. We've already talked about lines and stuff. So a linear function, you're used to y equals mx plus b. What we're going to do now is just use this function notation. So instead of doing a y, just put f of x. And that's read f of x. Right? You can make a note of that if you need to. It's not a multiplication problem. It's just saying the function is called f and x is the variable. Okay, so that just says f of x. Usually we use like f of x, g of h, h of x like that. That's function notation. Okay, all right. So the question on this is a vertical line a function? Well, a linear function would work like this. If it slopes up, that's a function, right? Because it passes the vertical line test. What if it's horizontal? Is that a function? Yeah. How about if it's vertical? No, because if you took a vertical line, it would go through every single point, right? So that's not a function. So a linear function is going to be a function except when it's vertical, okay? So what we would say on that, a vertical line is a vertical line a function, that would be no, okay? And that would be just because it fails the vertical line test, okay? It has to, all right? So a linear function is going to be a function except in that one case, all right? Okay, on the next page, next thing we want to do is just identify which of these are linear and which are nonlinear, okay? This is stuff you just look at in your head. So here's what you want to look at. Okay, we're looking at mx plus b, okay? So it's got to have all of those things in here, all right? So it's got to have mx plus b. It could be in a different order. It could be b plus mx like that. Okay, and it can't look any different than that. Okay, let's pick out which ones that you think are linear. I think there's only two of them there. I only see two. What do you think? Which ones are linear to you? A. Okay, that's okay. Mx plus b, it's backwards, that's okay. What else? D. Yeah, D is. Now, it doesn't have the mx, but you could really write this as 0x plus 12. That's no good because it's got a second power. That's no good because it has an absolute value. That's no good because x is in the bottom, and that's got a square root. So the only ones that are linear are going to be these two. So that's linear, and that's linear. Okay? And again, this thing right here could be written as f of x equals negative 3x plus 2. That way it's mx plus b. And then this one could be written as h of x equals 0x plus 12. The rest of them are nonlinear, okay? A lot of the stuff you'll do on your My Math Lab homework, some of these problems, about half of them are just going to be boom, boom, things you do in your head. You don't really need to do anything except just kind of understand the vocabulary. Okay, next thing we want to go through is now we're going to do some graphs of some nonlinear functions. So if you graph a nonlinear function, it's not going to be a line. It's going to be a curve of some sort. So again, we're still going to do this on table of values. So let's go ahead and do this square root of x. Okay. So first of all, what you want to do on this is you can't just choose anything you want for x. What kind of numbers can you take a square root of? There's only certain numbers you can do that at. What are they? Positive numbers. How about 0? Can you do square root of 0? Yeah. Can you do a square root of a negative number, for instance? No. Okay. The reason you can't do that is if I tried to do the square root of negative 4, you would be thinking what number times itself would give you negative 4, and there isn't such a thing. If you multiply the same number twice, you always get a positive number, right? Multiply two negatives, you get a positive. Okay. So what you're going to do is we're going to start with 0. And we're only going to do square roots of things that we can do in our head. I mean, you can do the square root of 2. That just requires your calculator. So I'm going to do square root of 1. What's another good number to use? 4 is a good one. What else? Not 8. 8 would be like 2 point something. Yeah, 9. Okay. I mean, it doesn't matter because, I mean, it still works. If you did square root of 8, you just have a decimal. So what I'm going to do is just use those numbers. So square root of 0 would be 0. Square root of 1 would be 1. Square root of 4 would be 2. And then square root of 9 would be 3, like that. Okay? And then we plot it. It's a nonlinear function, so its graph is not going to be a line. So if you plot the point 0, 0, that's your first point. Then you got 1, 1. Then over 4 up 2. And then over 9, you can extend the graph a little bit like that. And then it just goes like this and goes like that forever. So you can tell it's a curve. It's not a line. It's nonlinear. Okay? So again, that's just making a table of values is how you figure that out. And you want to make sure that you know that you can't do square roots of negative numbers. Okay? That's it. Okay? All right, the next one's really weird. This one, I'll have you do something with your calculator on this a little bit. So what I'm going to do with this one, it's also a nonlinear function. What I'm going to start with is let's put a 0 there, a 1, and a negative 1. Let's just start that way only. Okay? And then let's go out and let's do like negative 10 and 10. Okay? I'm picking those numbers because I want to show you kind of what happens on the problem then. Okay, well, let's start with 0. What do you know about 2 over 0? That's undefined, right? You can't divide by 0, so that one is actually undefined. So you can't do that. You won't have a point there. Okay, now let's do the next one. 2 over 1, that would just be 2. So that's a good point. Plug in the negative 1. That would be 2 over negative 1. That would be negative 2. So there's a couple of good points. If we go down to 10, we'd have 2 over 10. If you put that in the calculator, that would be, I think, 0.2 is what you would get there. Okay? And then if you do 2 over negative 10, that would just give you negative 0.2 like that. Okay, so that's kind of the way this goes. Now, to really get a good sense of how this graph goes, I want you to get your calculator out if you brought it, and we'll just put this one in together like this. Okay, one thing that you want to do when you go to y equals, make sure that the plot is not on. Some of you may have that plot on because you did a scatter plot in class. So if that plot is highlighted, you go up to it and press enter to unhighlight it because it won't graph if the plots are turned on. Then you go to y equals and then you do 2 over x. There's your variable key. Then we're just going to do this in a standard window. So just go zoom 6 to make it go from negative 10 to 10. Okay, and that's what the graph looks like. So what I'm going to have you do on this is we're going to learn about this later. Just put on the x-axis, just kind of draw a vertical line. You don't have to know too much about that yet. We call that a vertical, this is a good thing to write down. We call that a vertical asymptote. And it's just undefined there. And I'll explain a little bit how this goes on the graphing calculator here. Okay, so now if we plot these points, let's just plot these points. Negative 10, negative 0.2. That would mean you go way over to negative 10, and then you're just down a little bit below the x-axis. You just estimate the decimal. Then if you have negative 1, negative 2, you're like that. And then just sketch this in. It'll go towards the asymptote. Like the calculator shows, it kind of goes like that. Okay, that's what half of the graph looks like, is like that. Then if you go to the point 1, 2, you go over 1, up 2. And then if you go to, this would be 10 and 0.2, you just go over 10 and up a little bit above the x-axis, and then you just sketch this in kind of like that. So let me show you kind of what's happening on this problem. All right, and I'll see if this roughly makes any sense to you or not. Okay, so here's the idea. You can't divide by 0, but if you took a number that was real tiny, and I'm going to do this on the board, like we're doing 2 over x. If I plugged in something like 1 over 100, 1 over 100 is a tad bit bigger than 0, right? Okay, if I plugged that in, I'd have 2 over 1 over 100. What that means is 2 divided by 1 over 100. When you divide fractions, you flip the second one upside down, so you'd have 10 times 100, so it would be 200. Now here's what I want you to get out of this. See, if you're just barely to the right of 0, where does the graph go? It just gets bigger and bigger and bigger. If I change this to 1 over 1,000, then that's just going to become 2,000. So the closer that number gets to 0, the higher the graph goes. Tell me if that makes any sense to you. Okay, that's what happens. Now, if you go out here, if it's 2 over x here, and if you just let x be a super big number, like what if we took our graph all the way out to 10,000? Well, that number right there is getting very close to 0. That's still a little bit bigger than 0, though. So the further you go out this way, the closer that gets to the x-axis. Does that make any sense? Okay, that's kind of how this works, is that causes the graph to get real big, and if you go out there, it causes the graph to just get closer to 0. Okay, that's kind of a weird graph. We'll study about that a lot more a little bit later in the class. But now I want you to just kind of get a rough idea how that goes. Okay, let's go to this next thing. This is interpreting a graph. Again, these are things that you're learning the language on of the math on this graph. So I've got a graph that I've drawn here of a function, and this says y is equal to f of 5. Okay, so first of all, what f of 5 means is x is 5. If you see f of 5, that means x is 5. What is y? All right, so we're going over there. If x is 5, what is the value of y at that point? 0. Okay, that's 0. That's the 0.50. So that's asking for the y value when x is 5. That's what f of 5 means. Okay, so that would be just that 0.50. So that means y is 0. Okay. The next one means this, same thing. Find the y value when x is 0. So if x is 0, what's the y value of this graph? It's 90. Okay, so you're talking about that one then. So this next one is asking about this point. Okay, so that's 90. Okay, the next one is the same thing. It's saying x is negative 2. When x is negative 2, what does it look like y is approximately? Just estimate. What do you think? About 15, right. Okay, that looks like you're estimating that's negative 2, negative 15. Okay, so you want to get comfortable with what we call function notation. This is just saying x is negative 2, what's y? That's what f of negative 2 means. Now, this is asking the question backwards. So on this one, it's saying f of x is 150. So if f of x is 150, what that really means is y is 150. So you got to give me the x value. So what we're going to do is kind of work backwards on them. If y is 150, which is right there, what is x? 2. Right, so you're just asking that backwards. So that's really, this one is saying this. It's saying, okay, here's where y is 150. Your job is to find x, so it's 2. That's what that means, okay? Right? And if you go to the next one, this is saying y is 0. So if y is 0, there is actually more than one place on this graph where y is 0. How many places on my graph is y equal to 0? There's 2. This one and that one. So the x values would be negative 3 and 5. You can have more than one answer on these. Okay, so that would be right here and right here. That would be at negative 3, 5. So the purpose of this is to teach you the language of a function and to know what you're being asked on the problem. Okay, is everybody with me on what I'm doing on that? Okay, so go ahead and do the next ones here yourself, and then we'll check in just a couple of minutes here, and then we'll take a break after you do these problems. Just give you a chance to see if you know how to interpret this correctly. Some of these you might just have to estimate. You know, they might not be whole numbers, or just take your best educated guess. All right, so let's go ahead and see what we've come up with here. So part F, y equals f of 4. If x is 4, what do you have for y? It looks like 90, right? So that one is 90. Okay, the next one, if x is 1, what do you think y is approximately? What'd you put? About 130? Okay, that's just kind of ballpark. That's just estimating. Okay, and then if x is negative 1.5, negative 1.5 is here. So that looks like to me about 30. That's what I'm getting on that approximately. Okay. And then the next one, if x is negative 4, what do you have there? 20 maybe, something like that. Okay, x is negative 4, looks like that's around 20. All right, I got to be ballpark in that area. Then the next one is asking this backwards. So with this one, you're saying if y is 90, what is x? How many places on my graph does it look like y is 90? Probably 2. Probably here, probably there. This one is kind of hard to tell. Okay, I mean, I'm just going to bypass, although if you put that on there, it wouldn't matter. So it looks like x is 0 to give that y value, and over here it looks like x is 4. If you put negative 5, that's okay too, all right? And then the next one would be if y is 30. So how many places does the graph that is y 30? Looks like 3 places is what I'm seeing. So it looks like you're here, and you're there. So you're just going to approximate those x values. And it doesn't have to be exact. I mean, this one I would probably say is about, I don't know, negative 4.2, negative 4.3, somewhere in that range. This one looks like it's about negative 1.5. And then this one is maybe, I don't know, 4.7. I mean, it's just approximating anyway. The key thing is you want to make sure that you understand what I'm asking for in the problems. Is everybody clear with what I'm asking on those? Okay. All right, that's just the language. So let's go ahead and take a break. Is this idea of domain of a function, which we've talked about what that is, but now we're going to look at I give you a function and then you've got to figure out what the domain is. So what you're doing is we're going to focus on certain kinds of problems. We're going to focus on what's called a rational function. Like this example, x minus 5 over x minus 6 is a rational function. You have a fraction, you have what we call a polynomial in the top and a polynomial on the bottom. All you got to do on this is you got to see what makes this denominator 0. All right, so, and a lot of times you can just do this in your head, and everything else will work. So if I'm asking for a domain, I'm asking you what you could plug in for x that would give you an answer. And it turns out there's only one thing that wouldn't give me an answer. What would make that denominator 0 in your head? 6, right. Okay, so what you do, and you won't always be able to do it in your head, but what you want to write down is just, okay, set the denominator to 0 and solve that equation. If you can do it in your head, you can write the answer immediately. So that would be, you just solve that either in your head or show your work. That would be x equals 6. So actually the domain is everything except 6. So what we would do is we end up just writing this like this. Okay, we just say like this. We just say the set of x, and we just say x is not equal to 6. And if you write it that way, you're telling me that it's everything except 6. Okay, and the way that we call this set builder notation, that just says set of numbers so that x is not 6, but it can be anything else. Now on an interval, it would kind of go like this. So I want you to draw a number line, and I want you to put like a 6 there, and then put a bubble at 6, and then forever to the right, forever to the left. So actually, x can be any number except 6. Okay, so if you write this in an interval, you've got to break it up into 2 intervals. So you'd have to say negative infinity to 0, then 0 to 6. So you have to write this in this interval notation specifically like this. You have to say negative infinity to 6 with a parenthesis. Do you know why I put a parenthesis? To not include it. If you put a bracket there, you're telling me 6 is okay, and it isn't. Then we say union, and then 6 infinity. So by putting those parentheses, around the 6's, you're just saying, okay, it's everything except 6. Does that make sense to you? Okay? And use the union. I'm pretty sure my math lab wants you to use that union. And you can't use the letter U. You got to go to that toolbar and use that union symbol. So that's the two ways you would write this. Okay? All right, the next one's same way. What you focus on is what makes that denominator 0. You don't look at anything other part of the problem. So just write down 3x plus 4 is equal to 0. And then solve that equation. Okay, so you can subtract 4 from both sides. That's going to give 3x equals negative 4. Then you can divide both sides by 3 like that. Okay, then write it like this. Okay, for your inequality, you would just say set of x such that, that's just the terminology you use, and you say x is not equal to negative 4 over 3. So that's saying that x can be anything, but it can't be negative 4/3, because that's what makes it 0. Okay, and then for an interval, it's the same idea. Like on a number line, you would have negative 4/3 somewhere on the number line, and you would be forever to the right of it and forever to the left of it. So this one, the interval would be just negative infinity to negative 4/3 with a parenthesis, then union negative 4/3 to infinity like that. That's how that goes. That's what you do on a rational function, is you figure out what value of x makes your denominator 0. Does everybody understand that okay? Okay, if you can do it in your head, I don't care. You can do it in your head. A lot of times you can. Okay, so that's a rational function. That's how you figure out its domain for now. We're going to look at some other examples later in the class. Okay, go ahead and do the next two here, and I'll see how many know how to do number 2. I don't know if everybody will know how to do this or not, but you're just going to solve the equation 5x plus 10 is 0. That will help you write your answer. And then on the second one, I just decided I'd throw one of these out here just to see how many people know how to do that. Okay? I'll do something on this second one here. So this one you can do in your head. You just get 5x equals negative 10, then divide by 5, so you're going to get x is equal to negative 2. So you're telling me what x can be, so it can be everything, but it can't be negative 2. So you want to write that domain like that. Okay? Interval notation, you want to go negative infinity to negative 2, and then union negative 2 to infinity. Yes?
Do you not put another bar after?
Oh no, you just, this set builder is kind of like this. I even think our textbook doesn't care if you, I think they just want you to do that. Okay, you'll kind of on my math lab, they'll kind of walk you through how to do that. Probably the technical way to do that is just set of x 1 bar. That just means so that this.
Oh,
okay, so it's just 1 bar like that. Okay, that's just the way most textbooks are going to write set builder. Okay, now this next one, what you'd have to do is factor. Okay, so if you got your factoring down, this is what you would do. The first term would be x and x. Now you would have to find two numbers that multiply to give positive 6 that add up to 5. What would that be? It'd be 3 and 2, and they would both have to be positive, right? Okay. So then what you do is you solve each of these equations like this. So if you factor this, you've got to solve those two equations. There's going to be two numbers that cause that denominator to be 0. And you can do this in your head. That you can subtract 3 there. That would be x is negative 3. Over here you could subtract 2. That would be x is negative 2. So actually the way you would write this is you'd have to write it like this. You would just say set of x, and you would just say x is not equal to negative 3 comma 2. You can write it that way if you want to. All right, so it's everything except those two numbers. All right, negative 2, not 2. So they're negative 3 and negative 2. Now for an interval, it would kind of go like this. Like on a number line, you don't have to put the number line if you don't want to, but it would just be negative 3 and negative 2. You can't be that, but you can be everything else. So that means you'd have to draw 3 intervals. So the way you'd write your answer is you would say negative infinity to negative 3, because you're going left or right, and then everything between negative 3 and negative 2 is okay, and then negative 2 to infinity. So if you've got two numbers that cause the denominator to be 0. That's how you have to write it in an interval, is you've got to exclude the -3 and -2. And you're doing that left to right. Okay, does that make sense to everybody okay? Right? So you'll see that a little bit where you have to do some factoring. All right? So that would be how you handle a rational function, is just look at the denominator and figure out what makes it 0. That's it. That's what you focus on. Okay? All right, any questions about that? Okay, the next thing we're going to look at is a square root. We're only going to look at certain kinds of functions. So the type of numbers that we can take a square root of would be 0 or positive numbers. You can take a square root of 0, you can take a square root of any positive number. What you can't do is take a square root of a negative number. Okay, and that's the whole key to figuring out the domain, is to understand that. Okay, so here's kind of the idea. What I've done on here is I've just kind of told you what you do is you set up an inequality. So what you're going to do is you're going to set what's under the square root greater than or equal to 0. Okay, unless that square root's in the denominator. So if it's in the denominator, you're only going to do greater than. Okay, so let me just kind of give you the y part of this. Write down this function as an example. Let's say that we have square root of x minus 1, and then at the side write down f of x equals 1 over square root of x minus 1. So the answer to the domain is slightly different on both of those. So let me show you the difference. First of all, if you look at this, what kind of number has to be under the square root symbol? 0 or what? Positive. Good. Okay, so that means if it's 0 or positive, the way you find the domain on this is you just write down whatever's under the radical and you solve that inequality. Once you solve that inequality, you got it. So we would just add 1 to both sides, and what you would have is x is greater than or equal to 1. And you can write your domain that way if you want to. So what this is saying, let me show you, see if this makes sense. Okay, if x is 1, if you plug a 1 right there, you get 0, right? Square root of 0 is cool, right? Okay, take a number like that's bigger than 1, like 2. 2 minus 1 is 1. Square root of 1 is fine. If you take a number smaller than 1, though, like say 0, then what happens under the radical? You get a negative number, so it's no good. So as long as that's 1 or bigger, you're okay, right? So that's the idea. Now the difference on this one is it can't be 0. Okay, so that cannot be 0 because it's in a denominator. So what you would do on this is you would say x minus 1 greater than 0. See, if it's equal to 0, then you have a 0 denominator. So this one would have a slightly different answer. It would be x greater than 1. Okay, and to help you understand that, well, what would happen if x was 1? Then you would have 0 in the denominator, right? And you can't have that. So that one you're going to say greater than. This one you're going to say greater than or equal to because it's not in the denominator of a fraction. Does that make any sense? Okay, all right. So you got to be careful about those two things. Okay, now putting these together is actually pretty easy to do. It just depends on how well you can solve an inequality. And these inequalities are going to be pretty straightforward. So on this problem, what you're going to do is you're going to solve the inequality x minus 5, and we're going to say greater than or equal to 0. Okay, that's it. Okay, all you got to do is add 5 to both sides. And when you do that, you're going to get x is greater than or equal to 5. Okay, now the inequality, it's okay if you just write x is greater than or equal to 5. That's fine. Okay, and then if you looked at a number line graph, well, what this would mean on a number line is it would mean you're at 5, you're including 5, and you're forever to the right. So the interval on that would go like this. You would say bracket 5, comma, infinity. So all you're trying to do is figure out what makes x minus 5 bigger than 0, greater than or equal to 0. Okay, is everybody follow me okay there? Okay, all right. Now the next one, what you're going to do is this. Okay, it's slightly different. This is where you got to pay attention. Which am I going to do? Am I going to say greater than or equal to 0 or just greater than 0? Greater than, just greater than, because you can't be equal to 0 because it's in the denominator. So this one's slightly different. You got to pay attention to that. Okay, then you just solve the inequality. So what you do is add 3 to both sides. That would give 2x greater than 3. Divide by 2, so you'd end up with x must be greater than 3 halves. Okay? So what you would do is you would write your inequality for your domain like that. And then in interval notation, it's going to be 3 halves to infinity. But are you going to use a bracket or parenthesis on 3 halves? Got to use a parenthesis. Okay? So you got to do that. Okay? You guys understand the difference between the two in such a way that you can remember it. Okay? Remember, if it's in the denominator, you can't be equal to 0. That's why I say greater than 0. Okay? So that's what you do on those problems. Okay? Go ahead and crunch out the next two on this page. Just same idea. And crunch out your inequality. Okay, so on this first problem, did you do greater than or equal to 0 or just greater than 0? Which did you do? Greater than or equal to. It's okay for this to be 0 because it's not in a denominator. So you should have solved that inequality. Real straightforward inequality. You just subtract 9 from both sides. You'd have this, and then divide by 3. So you'd end up having x is greater than or equal to negative 3. So as long as you're negative 3 or bigger, then you're going to have a square root that you can do. Yes?
How do you determine which side the sine goes? Like the greater than or less?
Okay. Because on this one, you're doing a square root of this thing right here has to be 0 or bigger. So it's always greater than is going that way.
Yeah.
Okay, less than is going that way. Because what we're doing on inequality, what we want is we want the x on the left. So we want it to be larger than that number. Okay, that's how we know that. Okay. So what we'd say on this is we'd say x greater than or equal to negative 3, and what you should have done on your interval is just bracket negative 3 and then infinity. Okay, don't put a bracket on infinity ever. That's because it doesn't come to an end. It's not something that you're including in your interval. Okay, the next one, what you should have done is taken x plus 2, and what did you do with it? Greater than, not greater than or equal to. Does everybody understand that? Okay, so it can't be 0 because it's in a denominator. So you do that. So you'd have x greater than negative 2. So that would be your inequality. Then your interval would just be parentheses negative 2, infinity like that. Now, a lot of times students get an answer, but they never think about it. What you should always do is just think about it. If you were to plug in negative 2, wouldn't that give you square root of 0? That's no good. That's why we have a parenthesis. If you took a number bigger than negative 2, like negative 1, then you would have negative 1 plus 2 would be 1, and the square root of 1 is 1. It's okay. So the thing is, every number in that interval will give you an answer. Every number that's not in that interval will not give you an answer because you'll have a square root of a negative. That's what you want to make sure that you understand. So you can make sense of your answer by plugging numbers in. Okay, the next thing we'll look at is polynomials and linear functions, and it's just always all real numbers. Okay, so the domain of a linear function is always all real numbers, and it's basically because of this. If you have f of x equals mx plus b, well, the thing is, x can be multiplied by anything. All right, so if you think about this, you can't find a number that you are not allowed to multiply by something. Every single number on the number line can be multiplied by a number. So basically, you don't have a square root, you don't have a denominator or anything to worry about. And the other thing on this is a line just kind of goes on forever left to right. Okay, so it takes up every x value that you have. Okay, so it's always going to be all real numbers. And then I'll talk about what a polynomial is. Okay, so look at this one. Is this a linear function? Yes or no? Yeah, that's mx plus b. Okay, so that means the inequality. And what you don't really write an inequality, you just say all real numbers. Okay, you just have to write that in words like that. Now, what is the interval if it's everything? That's negative infinity to infinity. So if it's all real numbers, then you're just going to write like that. Okay, so if you know it's a linear function, then the domain is everything. Okay, everything works. Okay, now this one is called a polynomial. Now, a polynomial is just when you have x to a power, and those powers have to be whole numbers, then you're just adding and subtracting numbers. Okay, the same thing on this, and what you're thinking about is, if you think about it, any number that you can think of can be raised to the third power. You couldn't give me a number that you would not be allowed to multiply out 3 times. Same thing there. You can take any number and multiply it by itself. So x could be anything. There's no number x that would cause you to get something that's undefined. Does that make any sense to you? Okay, so everything works on this one because it's a polynomial. So what you'd end up getting on this then is the same basic answer with this then. Okay, so what we'd have is to press that button again that sometimes I accidentally hit. Okay, let me close this real fast and reopen it. Yeah, okay, so what you'd end up having with here then is same thing. It'd just be all real numbers. You can just write it like that if you want to, and then it would be negative infinity, infinity. So what I'm saying on a linear function, is there any number that cannot be multiplied by 2? No. Okay, I mean, anything works. Is there any number that can't be raised to a power? No. So you're always going to get all real numbers when you're looking at linear and polynomial functions. Okay, the next thing is difference quotient we're going to talk about in a little bit. I'm not going to talk about this yet, but a little bit further in your handout, we're going to talk about difference quotient and work with that, because you're going to need to know that if you're going to take business calculus next semester. So let's go on to the next page, and what we're going to do is evaluate functions. So what I'm doing on this is I'm giving you a function, and if I want you to find f of negative 2, all that means is everywhere you see an x, you just plug in negative 2. And you want to use parentheses, so you want to write down f of negative 2 is 2 times negative 2 squared minus 1, and then it's just a matter of doing your arithmetic, okay? And you got to follow order of operations. You got to do an exponent, then multiplication, then subtraction. So I'm going to have 2 times 4 minus 1, okay? Then multiply 4, you subtract, so that's 8 minus 1, so that's equal to 7. So f of negative 2, it just means if x is negative 2, the y value on that graph is 7, okay? That's what that means, okay? And then the same thing with f of 0. F of 0, all you're going to do is replace x with 0. So you're going to have 2 times 0 squared minus 1, and then work out the arithmetic. Okay, do the exponent first, which is 0. So 2 times 0 minus 1 would be 0 minus 1. So that's going to be negative 1. Okay, that's what that is. Now I'm going to show you something on my graphing calculator. I want you to just watch this. You don't have to do this on your calculator, but if I put in the function that we're working on, 2x squared minus 1, and if I graph that in a standard window, it's going to give you a parabola, and I want to show you this. Like if I traced it negative 2, you can check your answer this way. So on this first one, if you trace it negative 2, it's going to give you that y value of 7. Okay, if you want to trace it 0, then it'll give you the answer of negative 1. So all you're doing is finding a y value for a specific x. That's what you're asked to do, okay? The next ones have variables in it, so it's the same idea. If you're doing f of a, all you're going to do is where you see x, put in an a. So you would have 2 times a squared minus 1. And that's it. There isn't anything you can do with that because a is a variable. You don't know what it is. Okay, so you would have that. Okay. The next one is f of 2a. So what you're going to do on f of 2a is you're going to have 2 times x squared minus 1. And again, what you're going to do is just plug into that parenthesis 2a like that. So whatever's in that parenthesis, you plug in for x and then you work it out. Okay? All right, you want to be kind of careful when you do this. Okay, what is 2a squared means 2a times 2a. What's 2a times 2a? 4a to the second, right? A times a is a to the second. So that's going to give you 2 times 4a to the second and then minus 1. So what's the answer going to be? 2 times 4, all you got to do is 2 times 4, so what do you get? 8. A to the second minus 1, right? Okay, so just working out the algebra on that. So that's 8a squared minus 1. You plug in and then you calculate. Okay, the next one goes like this. F of x, so see the function we're working with is 2x squared minus 1. A good way to do this problem is just write down the function, but instead of putting x, put a parenthesis, and what goes in that parenthesis is x squared. Okay? So what happens if you do x squared and square it? What's x squared times itself? X to the fourth, right? Okay, you add exponents, okay? X to the second times itself is x to the fourth. Because all it means is, it just means that you have 4 x's. X squared is x times x, so you have 4. So that is going to leave you with your next step as 2 times x to the fourth minus 1. And there isn't anything else you can do with that. So it's 2x to the fourth minus 1. Okay, that's just basic algebra. Okay, the next one you're going to do the same thing. We're going to do f of x cubed. That should have been x squared there. F of x cubed is going to be 2 times something squared minus 1. Okay, so we're going to plug in the x cubed, and we're going to work that out. Okay? What is x to the third? What would happen if you did x to the third and multiplied it by itself? What would you get? X to the sixth. Okay? And if you don't know this from your background, it'll start popping up. Anytime you take a power to another power, you multiply. That's 6. Okay? So you would end up having on this, you would have 2x to the sixth, and then minus 1 like that. Okay, that's the little things that you're going to see with, basic algebra skill with exponents and so forth. So you want to make sure you review that a little bit. Okay, then the next one would go like this. If you do f of square root of x, okay, again, we're doing 2 times something squared minus 1. So I'll see what you all know on this. Okay, do you know what happens if you take a square root and then raise it to the second power? It gives x, because what that is that's square root of x squared. And when you do the square root of something squared, that's the opposite. So it just gives you x. So what you would have here is 2x minus 1 like that. So there's some little algebra that's going to come up in these problems that you're going to have to review a little bit as you're doing these. But that's what we call evaluating a function. Okay? So I'm going to give you a little bit of time to take this function, and this really should have said f of x equals x squared plus 2x. Just do the next 6 and see if you can kind of run through what I just did. Okay? And then we're going to get into the difference quotient. We're going to work on that a little bit today too. I just want to be kind of careful with your arithmetic and your negatives and that kind of thing, and see what we get here. So that one is second round. Got a third round. So you're taking that function. So you're going to do -3 in parentheses, -3 to the second plus 2 times -3. Everybody's got a different answer on A. Everybody that I've looked at so far has a different answer. Now, see, you're doing that function. We're not on that function. Okay? So you're doing f of x equals x squared plus 2x. Okay? However, everybody's getting the second one right. Everybody's getting the same answer on that. Okay, let's see, you want to work that out. So you want to do, you want to do write it like this, -3 to the second plus 2 times -3. Plug it into there. Now, if you square that, -3 times -3 is 9. That is -6. Okay. What are you guys getting on the first problem? What? 3? Okay, that's what I'm looking for, is 3. I'm seeing a lot of different answers. You plug it into that, x squared plus 2x. See, that's a negative. So -3 squared.
Yeah.
That's why I messed up. Yeah, it's the first one's 3. Second one's 0. I'm seeing people get the second one. Because you're doing -3 squared plus 2 times -3 is arithmetic. Yeah, you got it written down, but that's 9. If you square -3, that's 9.
Yeah.
Because -3 times -3 is 9, so you'd end up having 9 minus 6.
Okay.
So you'd have 3.
Yeah.
Say, let me see your pencil for a second. Okay, one thing that you want to do is that needs to be in a parenthesis. Anytime you're plugging in and squaring, it's in parentheses. So -3 times itself is 9. So you end up having 9 plus -6. That's where 3 comes from. Okay, so that's got to be 9 when you square that. What's that?
Is D15H?
No.
Okay.
We're going to find out in just a minute. I think D would be 9h to the second plus 6h.
Yeah, that's what yeah, okay.
Yeah, okay.
Yeah.
Yeah. Okay, so let's go through these, and then I want to work probably most of the rest of the time on the difference quotient. So, okay, this one you should have done parentheses, -3 squared plus 2 times -3, and you got to write that in parentheses like that. So that would be 9, then -6, so that's 3. Okay. The next one would be 0 to the second plus 2 times 0. So that's 0 plus 0, so that one's 0. Okay, those are just the arithmetic. Now the next one, all you're going to do on this next one is everywhere you see an x, you're going to replace it with h. So that would be h squared plus 2h. All right, so that's the variable x changes to h. So that's all you do with that one. Okay, the next one, I don't know how many people were doing this one too well. So what we're going to do is something squared plus 2 times something. Well, what we plug in is 3h. So on your paper, I think it's pretty important you write it that way. Parentheses 3h squared plus 2 times 3h. Okay, if you do 3h times 3h, what is that? That's 9h to the second. And then if you do 2 times 3h, that's 6h. And that's the answer because these are unlike terms, so you can't go any further. Okay, that's what that is. If you had 15h, I think you were thinking like terms there or something. I saw that on several papers. Okay, the next one goes like this if you're doing x squared. So again, we're doing something squared plus 2 times something. Okay, the something is x squared. So I'm going to plug that in. Then we'll see kind of what we got on this. So what is x squared to the second? X to the fourth, because you multiply those exponents, and then plus 2x to the second. Now those are unlike terms, so you can't do anything else with that problem except write it like that. Okay, is everybody with me there? Okay, right, and then the next one you go like this. Something squared plus 2 times something. We're doing x squared plus 2x. So again, just replace the x with x to the third, and this will work out a lot like the last problem. So what's x to the third to the second? This first thing. X to the sixth, and then 2x to the third. Those are unlike terms, so you can't do anything else with that problem. That's it. Okay, so do you guys got any question about any of the details of the algebra? Yeah.
So if you have the x cubed, the x to the third, and then you're taking the 3 and adding instead of squaring it.
Well, this right here, you're squaring right here. This part right here, you're squaring.
Right.
And what the meaning of that is x, anytime you square something, you multiply it by itself. You add the exponents. The reason you add the exponent is because x to the third is x times x times x. And then this other x to the third is x times x times x, so there's 6 of them there. Okay, that's why you're doing that. The other way to look at this is anytime you raise a power to another power, you multiply. 3 times 2 is 6. There's 2 ways you can do that. It's really helpful if you understand why that is, because it'll sink in with you a little bit better. Okay? Okay, now here's where the fun begins. Okay, now you got to work with these a little bit, and a lot of this will kind of challenge your background a little bit with your algebra. Now we're going to do the difference quotient and work this out. So this is called the difference quotient. We're not really going to talk about what it is today. This is an algebraic expression that has something to do with slope and rate of change, and we'll get into that later. So what we're going to do is take a function that I give you and write it in this difference quotient. Now this is what I want you to do on this. First of all, start by just writing down this difference quotient. Write it down, f of x plus h minus f of x all over h. And then I'll show you how to put this together. And watch carefully, because sometimes students, when they're learning this, struggle with putting it together. So this is the way I'm going to show you. What I want you to do is put a big fraction, have a minus and have a bracket there, and a little bit bigger bracket there. Okay, when you set up a difference quotient, you just got to get everything set up correctly. So here's how you're always going to do this. Okay, f of x is whatever I gave you. So what goes in this second bracket is 2x plus 3. That's always the same. Whatever I give you goes there. Now, f of x plus h is going to go here, and all that means is you're going to replace this x with x plus h. So they're going to look exactly the same with one difference. So what goes here is 2 parentheses x plus h plus 3. Okay, let's look at this a little bit, because once you get the hang of how to set this up, then that's the first battle you got to do. So what goes here is whatever I gave you, right? What's the only difference between this and this? There's only one difference. The x became, well, that should be x plus h, not 3. I don't know why I put a 3 there. So it should be 2x plus h plus 3. Why I did that, I have no clue. So let's get that corrected. Okay, so it goes like that. Do you guys see what I'm doing there? Second bracket is what I give you. First bracket is the same thing, except change the x to parentheses x plus h. Okay, is that clear? It will always be the same. Okay, that's what you got to do, is put it together that way. Now what we're going to do is we're going to simplify this. Okay, we're going to do a distributive property there. So that's going to be 2 times x is 2x, 2 times h is 2h. Then we have plus 3. Okay, that 2 doesn't multiply by the 3. Now, the minus sign, what does this minus sign do to the second bracket? That's real important. Changes signs, right? You're distributing through that. So that's minus 2x and minus 3. Then it's all over h like that. Okay? So that's what you got to do. Now, does anything cancel in the numerator now? Yeah, what cancels? 2x, what else? 3 is good, okay? You'll always have a bunch of things canceling. So write down what you're left with. You're going to be left with 2h over h, and then that divides out one of the h's. Okay, so this is basically going to go out. H over h is 1, so the answer to that problem is 2. That's called a difference quotient. What you will find in calculus is that's the slope. Now see, this is a line. What's the slope of that line? 2. That's what we got. Okay. Now it's on a linear function, you can always tell the answer because it's the slope anyway. So that's the idea. Okay. All right, let's set this next one up. We're going to only do this on a couple of types of functions. So this next one, same way, just write f of x plus h minus f of x all over h. Okay, you want to write down the difference quotient, and then I'll show you how to put this together. Okay, so what I usually like students to do is have 2 brackets. The second one's kind of small, and then the first one's going to be real big. Okay, and if you can get this set up, that's half of the battle. Okay, now, what goes here? What did I say goes there? Whatever I gave you, f of x. Okay, so in that second bracket, go ahead and just put in what I gave you. That's a good way to start, is like that. Okay? Now, the only difference between this thing and this, what's the difference going to be? All these x's get replaced with parenthesis x plus h. That's what f of x plus h means. So what you're going to do here is you're going to do this. Okay, instead of putting x squared, put parentheses x plus h squared. Instead of putting 2x, put 2 parentheses x plus h. And then the 1 just stays alone like that. So when you're processing, setting that up, the last bracket's what I give you. Second bracket, change all the x's to parentheses x plus h. Does that look clear? Tell me. Sometimes students look at this and it just goes right through their head. Okay, try this approach, and then after teaching this about 30 years, this is probably the simplest thing I've come up with. Whatever I give you goes there. Don't even question it. What's the difference? This turns into that, that turns into that. That's it. They're the same except x turns into x plus h. Okay, now what we're going to do is we're going to work all this out. So the first thing I'm going to do is I'm going to work out the x plus h squared. Now I'm going to do this just kind of at the side of paper. I'm going to FOIL that out. Okay, so I'm going to FOIL that out. So the first term is x squared. The outside term is plus xh. The inside term is another xh. It doesn't matter what order you put that in. You can say hx or xh, the same thing. And then the last term, h times h, is h to the second. And then these are like terms. So you have 1 plus 1 of those. So you have x squared plus 2xh plus h squared. Okay, I just FOILed x plus h squared. Okay, so what I'm going to have you do is replace that, what I have in yellow, replace that with x squared plus 2xh plus h squared. That required that you FOILed that and multiplied that out. Okay, now moving on from here, you're going to distribute the 2, so that's going to be 2x plus 2h, so we have plus 2x plus 2h, then we have the plus 1. Okay, so what I did is I FOILed the x plus h squared, distributed the 2, brought down the 1. Are you clear with what I did there? Okay, now what does this thing do here? What does that minus do to everything here? Changes to minus, 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 right? Okay, so we're going to take off the brackets. Now, so you don't really need the brackets anymore after you've done that, so I'm just going to take those off. Then what I'm going to do is change those signs. So it's going to be minus x squared minus 2x minus 1 all over h. Okay? Now, do you see in the numerator anything canceling? I hope. Okay, you always will. Okay? And this is going to be a big deal if you're going to take business calculus. We do this all the time. So that cancels. Let's see, the 2x's cancel and the 1's cancel. So what we're going to have left is these 3 things all over h. So we're going to have 2xh plus h squared plus 2h all over h. Okay, now what will always happen on these problems is if you do everything correctly, that h will cancel out at the end. So what we're going to do is we're going to factor this numerator. I'm just going to take an h out. See, there's an h in every position of the numerator, so I take an h out, then I have what's left. So h has to be multiplied by 2x to get that first term. H has to be multiplied by h to get h squared. Then h has to be multiplied by 2 to give that. Okay, so you're factoring. You're taking out common factors. Now you can wipe out the h's, and that's as far as you can take this answer. So those things cancel out. So you get 2x plus h plus 2. The only way to get this down good is to practice it a lot. So the idea with that is you want to get it set up, and then all the algebra is going to work out. You'll have a bunch of cancellations, and that h will cancel out the end. Okay? And we'll work on that a little bit more next time. That'll be one of the more difficult things you're going to learn, probably the most difficult thing to learn in this section. But you can do it, okay? And we're going to limit it to linear and quadratic functions. We're not going to do too much more than that, okay?